How about this? Hello, can you hear me? Gia? What's Gia? Is it a yes? Oh, it's not here. I thought there's a Gia. Hello, everyone. Can you hear me? Hello. Hello. Wait, I will change it. Is this? Hello. Hello. Oh, sorry. Not the speaker. Should be this on. Hello. Can you hear me? Hello. My God. Mm. Ah, okay. So yes. Okay. I'll start now or not yet. Oh, my camera. Okay, it's there. Mm, I guess I will finish for the review today. So for the next meeting, maybe we will not meet online. I'll just upload some materials there. Okay. By the way, if you still have some um, copies of previous questions, you try to answer them because maybe the questions are related to that one. Okay. So do not just review the midterm review part. Okay. So you study also the slides. And if you can find some previous questions that are different from our review, you study that one also. Okay. Okay. So start now. By the way, I forgot something. One topic, and it's there in the part two, slide number 37. Yeah, I forgot to discuss this one, but I give you an example of this already in the review. Okay, so we will start here first. Double integrals in polar coordinates. Wait. By the way, who are in the classroom? Are you there in the classroom? Is it ready there already or not yet? Who's in the classroom? Is it okay now to start? Say yes, please. Yes? Okay. Someone say yes. Okay, let's start now. Yes, we are ready. Okay. Mayday, can you open your slides there? Chapter 2, part 2. So we have this as an example. Um, so you have this circle here, x squared plus y squared is equal to 1. So this 1 is the region. If your region R there is a circle, then you had to use this one. Double integrals in polar coordinates. So double integral of your f x y under the region R dA. Now your region R here is the set containing R theta, the points R theta, such that your radius is from 0 to 1. For this one, you have there x squared plus y squared is equal to 1. This is r squared is equal to 1, right? So your radius is equal to 1. So it started with 0 because it's here. It started at 0, 0 point, right? Here, the origin, going there to the radius, which is equal to 1. And your theta is from 0 to 2 pi because it starts here. It's 0. Then when you have the full circle, it's going to 2 pi. Um, Now we have this. At the other side, we have two circles here, and in the region R is only this one with a color, with a shade of it looks like orange. Is it orange? Okay. Now, on the inner circle here is x squared plus y squared is equal to 1. Then the outer circle is, or the bigger circle is x squared plus y squared is equal to 4. Now, your radius here started from this one going there. So it's from 1 to 2 for your radius. And now for your theta, because this is only half of the circle, it's from 0 to pi. Your pi is here, right? Pi is equivalent to 180 degrees. So that's from 0 to pi. And in your formula there, if you have the f of xy, if you can find it there like x squared plus y squared, you have to replace that with r squared because solving the double integral here is we change the variable from x to y and then we use now r and theta in solving the double integral. So your x, you replace that with r cosine theta. If it's not like this, if it's not like x squared plus y squared, if it will not form this one, so y is equal to r sine theta. Okay? And then your dA there is equal to r dr d theta. Yeah, it's here. This is your dA. Your dA is r dr d theta. So your f of xy now becomes your x replace that with r cosine theta, then your y is r sine theta. So we have this one here. And now for the numbers here in your double integral, since this is dr here, the first the one who is in the inner integral, which is here dr. So your r is bounded from a to b, so you have to write it there a to b there. And then your d theta is bounded from alpha to beta, so you have the alpha to beta. Okay. So we have this as an example. Um, Evaluate the double integral of 3x plus 4y squared dA, where R is the region in the upper half plane bounded by the circles x squared plus y squared equals 1 and x squared plus y squared is equal to 4. And we have this already for the bounds for your R and theta. So it's here in the drawing. Your R is bounded from 1 to 2 because the radius here is 1 and the radius here, this is 4. So R squared is equal to 4. Your R here, or the radius here is equal to 2. Correct? So that's 1 to 2. And then your theta is from 0 to pi. So we have to substitute that or we have to use that here in this problem. So it's here 0 to pi and then your R is from 1 to 2. Now you replace the x there. That is 3x. So replace the x with r cosine theta. And then your y squared. So copy 4. Then your y squared becomes r squared sine squared theta. Okay. Now your a, replace your a there with r dr d theta. And then you have this. Your theta is from 0 to pi. the number for your r, the integral, you have it from 1 to 2. So 1 to 2 here in your inner integral, and then the outer integral, it's from 0 to pi. Now, the technique here, class, is the shorter way of solving it is this. You multiply r first here, you distribute the r there, and solve its integral. So solve the inner integral, and then after that, you can calculate that directly with your calculator. So no need for you to solve the integral anymore because you have an integral there in your calculators already, right? Yeah, that's it. By the way, your generation is still lucky because during our time when I was studying in university, our calculators cannot solve integral. That's it. Okay, so we start now. Multiply the r first, so this becomes 3r squared cos theta plus 4, and then multiply the r there. It becomes 4r cubed sine squared theta. Okay, now the integral of your r squared, only your cosine theta here and sine squared theta are considered constant because we are integrating with respect to r first in your inner integral, right? So r squared becomes r cubed over 3, so we can cancel the constant 3 here. So we have the r cubed cosine theta, just copy the cosine theta, plus your r cubed there becomes r to the fourth over 4. So we can cancel the 4 also. So we have r to the fourth and then copy sine squared theta. Evaluate that. Evaluate this from 1 to 2. Now you substitute 2 here. We have 2 cubed. That's 8 cos theta. And then when you substitute 2 here, 2 to the fourth, it's 16. Um, 16 sine squared theta. Now when you minus the 1 there, so minus 1 with your cos theta. So this becomes negative cos theta. So 8 theta minus 1 cos theta becomes 7 cos theta. And then here we have 16 sine squared, right? So when you substitute the 1 here, it becomes 1 to the fourth. It's 1. So minus 1 sine or minus sine squared theta. So your 16 becomes 15 sine squared theta, and then we integrate this again. For this one class, you can stop integrating this anymore. You can type this in your calculator, and your calculator will give you 15 pi over 2. Okay. By the way, your calculator there should be in rad mode. You try to calculate this with your calculator, and it should be in rad mode, and you can get this answer. Okay. Because in the exam, you should be in a hurry in solving the answers because your time is limited. Now, for your projects or quizzes that if we can have, you should integrate this in detailed solution. So we have this one, copy 7 cos theta, and this is 15. By the way, your sine squared theta, we have an equivalent of this. It's equivalent to 1 half, and then times 1 minus cos 2 theta. So that is why it's like this here now, 15 over 2, and then times 1 minus cos 2 theta, because it's easier for us to get the integral of this. Okay, now integral of 7 cos theta is 7 sine theta, and then next 15 over 2 times 1 here, it's constant. So integrating it to theta, we have just to write theta beside it, right? We have 15 theta over 2 minus, so when you multiply here the 15 over 2 cos 2 theta, it becomes 15 over 4 sine 2 theta. This is the integral of your cos 2 theta. And then evaluate this from 0 to pi. Now when you substitute pi here, it becomes 0 in the sine pi. Pi here is a 15 pi over 2 actually. So only this one will give you the answer because here we have sine of 2 pi. It's also 0. Then when you substitute here 0, sine 0 is 0. And then sine 2 times 0 here, it's also 0. When you substitute 0 there, and when you substitute 0 here in your theta, it's 15 over 2 times 0. It's still 0. So only this part here, when your pi is substituted here in the 15 pi theta over 2, substituting pi there, that's the value actually, 15 pi over 2. And we're done. Okay, so that is first example. Next example, if you have this, find the volume of the solid bounded by the plane z is equal to 0 and the paraboloid z is equal to 1 minus x squared minus y. The graph of this, when you say plane z is equal to 0, it should be here, the plane in the xy plane, because it's z is equal to 0 there, right? And then we have z is equal to 1 minus x squared minus y squared is this one. So it looks like a bowl. Yeah, a bowl. Bowl class, not ball. Okay. And that's it. Um, Next is, if your z there is 0 and you make this 0 here also, we have x squared plus y squared is equal to 1. Correct? Here is 0. Make this 0 here. So transfer the x squared and y squared to the other side. It becomes x squared plus y squared is equal to 1. This means that the plane intersects the paraboloid in the circle x squared plus y squared is equal to 1. So the solid lies under the paraboloid and above the circular disc. It's here. It's above the circular disc. And it says under the paraboloid because the paraboloid is that graph there. So it's under it. And then given by x squared plus y squared is less than or equal to 1. Yeah, because you include all the points there inside the circle. So that is why it's less than or equal there. Now, for your radius here, so it's easy to see that the radius is from 0 to 1 because this is your circle, right? X squared plus y squared is equal to 1. So the radius is from 0 to 1. Now for your theta, so as you can see, this is a full circle. So that's from 0 to 2 pi. Okay? So in your double integral, um, we solve the double integral of the z only because this is your paraboloid. This is the only um, this curve here. This is the graph, right? So we integrate the double integral of that z dA. And your z there is equivalent to 1 minus x squared minus y squared dA. Now, as you can see here, you can form actually the x squared plus y squared here if you factor out the negative here. And then after that, replace that with r squared, correct? Because your r squared is equivalent to x squared plus y squared, right? And I told you if you can form that one, you have to replace that with r squared. And that's it. It's now 1 minus r squared. Your dA becomes r dr d theta. So as you can see here, there is no x and y anymore. So you can integrate that. Now for the r, it's from 0 to 1, which is this. And then theta is the last one there. So your last integral is, or the outer integral is from 0 to 2 pi. And now we can do separation of variables here because the r's are here. And then so you can transfer the d theta there. And then the integral of this from 0 to 2 pi, d theta is 2 pi. And then this one, you can calculate this separately with your calculator. And then this one also with your calculator. Multiply the r there or no need. Just type this in your calculator, the inner integral. And that is actually equal to this. And it will give you a value which is equal to, this one is 2 pi. And then this one is equivalent to 1/4. You try that in your calculator. This is 1/4. Then you multiply them. The answer is pi over 2. So if we solve this using integration, okay, not your calculator, so we have there 2 pi, and then integrate r, we have r squared over 2 minus here r cubed becomes r to the fourth over 4. Integrate that from 0 to 1. Now we substitute 1 there. No need for you to substitute 0 because all of that will become 0. So this becomes 1 squared. 1 squared is 1, and 1 to the fourth is also 1. So 1 half minus 1/4, it's 1/4. times 2 pi, it becomes pi over 2. And this is now your volume. Okay? Bounded by the two curves c equals 0 and z is equal to 1 minus x squared minus y squared. Now, what if your r or your radius is bounded by functions? Here we have h1, yeah, function of theta, h1 of theta, and then h2 theta here. So what to do? Almost the same with our double integral. It's just that uh, it's a function here, h1 theta, and then going to h2 theta there. Okay? Again, it should be a function of theta. So we have this example number 4. Example number 4. Find the volume of the solid that lies under the paraboloid z is equal to x squared plus y squared above the xy plane. And inside the cylinder, x squared plus y squared is equal to 2x. Okay, so what are we going to do first here is we get this x squared plus y squared is equal to 2x. Okay, now we do completing the square. We minus because it says they're inside this cylinder, right? So we will graph this. So to graph that, it's easier if we do completing the square first. You transfer the 2x there to the other side, it becomes x squared minus 2x. Okay? Plus y squared is equal to 0. Again, when you transfer the 2x to the other side, it becomes minus 2x there. X squared minus 2x plus y squared is equal to 0. Now, to make it complete, your x squared minus 2x is complete if you add it with 1. So you have to add 1 here, the left. You add 1 also at the right side. So that is why there's a 1 here. And then if you add 1 there, your x squared minus 2x plus 1 becomes x minus 1 squared. And then your y squared, just y squared. And then it's now equal to 1. It's not equal to 0 anymore because you add 1 the left side and then you add also 1 on the right side of the equation. And it should be because if you add 1 here and you didn't add to the right side, then it's wrong. Now, it's easy now for us to see what is the center of the circle. The formula for the circle is we have x minus h squared plus y minus k squared is equal to r squared. And then the center is the hk. Now, if you can see it there, x squared plus y squared, your h there and k are all 0. That is why the center there is the origin, 0, 0. But here, it's not the 0, 0 anymore. The center in this square, a square circle, sorry. In this circle here, we have 1 as your h here, and your k here is 0. Your k is here in your y. Again, it's y minus k squared. So your h here is 1. So 1, 0 is the center. And then since the radius here is equal to 1, so r squared is equal to 1, the radius or r is equal to 1 also. So that is why we have here 1 and then draw the radius. It should be 1, 1 there. So it should be 2 here. Correct? And this is from 0 to 2. And then draw a circle. Now, what is your radius? Why is it 2 cos theta here for the radius? And then you will say like, why is it 2 cos theta? We thought it's 1 because it's r squared is equal to 1 here. Okay. By the way, um, you are going to get the radius here. And your x squared plus y squared is equal to 2x. Okay. So when we solve this one also, we use polar coordinates, right? What's the value of your x again? Your x is 2r cos theta, correct? No, no. Oh, yeah. It's r cos theta. And then says there's a 2 here outside. It's 2x, right? So the 2x becomes 2r cos theta. 2r cos theta. Now, that 2r cos theta is equal to your r squared because this is the placement of your r squared, right? X squared plus y squared is equal to r squared in the formula. So your radius r squared is equivalent to 2r cos theta. Now divide both sides by r because there's an r there. Your r now is equal to, yeah, the r squared becomes r because you divide it with r. So r now is equal to 2 cos theta, correct? Again, we get the r there from this, 2, 2x, and then that's 2r cos theta. Then that's 2r cos theta is equal to r squared. Then after that, you divide r both sides. Then cancel the r there. We can do that because your radius is positive. Then you can cancel it. You have there r is equal to 2 cos theta. Okay? And you have that. Next is in polar coordinates, your x squared plus y squared is equal to r squared, correct? Which is this. We will, since we're going to get the volume of the solid that lies under this paraboloid, z is equal to x squared plus y squared. So you have to get the double integral of this x squared plus y squared, and then replace that with r squared because that's equal to r squared. And there's the explanation here about your radius. It's here, x is equal to r cos theta. So your r squared there is equal to 2r cos theta because that's equal to 2x. You can divide it r both sides. So your r there is equal to 2 cos theta. Thus, the disk d is given now by, so the radius is from 0 to 2 cos theta. And then your theta is from negative pi over 2 to pi over 2. Look at the circle here. It's here, right? And then and the cylinder is formed like this here. So look at the degrees, the theta. The theta is from negative pi over 2 to pi over 2. That is your disk D there at the lower part. Okay? Now we solve the this one. Um in your integral, the x squared plus y squared becomes r squared now. Then dA, replace that with r dr d theta. Now for your r, it's from 0 to 2 cos theta. And then for the theta, it's from negative pi over 2 to pi over 2. And then now this is r squared times r. Will become r cubed. So the integral of your r cube is r to the fourth over 4. Integrate this one from 0 to 2 cos theta. Now substitute it here. 2 to the fourth, it's 16. Divided by 4, it's 4. That is why there's a 4 here outside. Then the cos theta, you raise it to 4 also. So that's cos to the fourth theta d theta. Now, class, your calculator can solve this directly. And please try this part here. It will give you 3 pi over 2 because this one is a long method and you don't need that when you take the test. Okay? But you need that in your project if you have, because in your project is it should be in detailed. You write it in detailed. Okay. Um this is 8 and then 0 to pi over 2 cos 4 theta d theta. Okay, as you can see here, the integral from here is from negative pi over 2 to pi over 2. And um, this is an even function, cos to the power of 4 theta. And since this is even function, um, the integral from negative pi over 2 to 0 is equal to the integral from 0 to pi over 2. So that is why we cut the integral from 0 to pi over 2 and we have to multiply this by 2. That is why the 4 there becomes 8. Okay? And now the cos to the power of 4 theta. They separate this one. They make it like cos squared theta squared. Now the cos squared theta is equal to this 1 plus cos 2 theta over 2. Then the squared is here. The squared is here outside d theta because this is equivalent to your cos squared theta. When you squared it, it's cos to the fourth. Okay? Cos to the power of 4. And now, um, 2 squared is 4. You divide it here. So 8 divided by 4, the answer is 2. That is why there's 2 here. Now you square this. What is the square of 1 plus cos 2 theta? If you square that, 1 squared is 1. And then cos 2 theta times 1. Then another cos 2 theta times 1. We have there 2 cos 2 theta. Then plus the cos squared 2 theta. Correct? Because you square the cos 2 theta. And that's it. The cos squared 2 theta is equivalent to this 1 half times 1 plus cos 4 theta d theta, so that it's easier for us to integrate this. You have here 1 and then this one is 1 half here. 1 half times 1 is 1 half. When you add it, it's 3 over 2 and that's the constant. So 3 over 2, you just multiply it with theta. You solve now the integral of that. Now the integral of 2 cos 2 theta is this, the sine 2 theta, because the integral of cos 2 theta is 1 half sine 2 theta. So 2 times 1 half becomes 1 here. And the next we have 1 half cos to the fourth theta. So that is 1 half. And then multiply that with 1/4. And then sine of 4 theta. Now you substitute there the pi over 2. No need for you to substitute the 0 because all of that will become 0. So just substitute here pi over 2. So we have here 2 times 3 over 2. Substitute the pi over 2 here. We have that one. Oh, so when you substitute pi over 2 here, that becomes sine pi, and sine pi is 0. And when you substitute pi over 2 here, 4 times pi over 2, it's 2 pi. So sine of 2 pi is also 0. So only this one will give the value. So 2 times 3 over 2 times pi over 2, then the answer is 3 pi over 2. And that's it. Next. Okay, we're done with the questions with polar, what is this? Double integrals in polar coordinates. Okay, so it's there in your chapter 2, part 2. And in our midterm review, we are done with the part 1 already. Are we done with the part 1? I guess so. Um, the one that's here in my record is we are now solving review number 8, part 2. We are now in the part 2, number 8. We are done with this, right? This is now the number 8. Yeah, we will start with this saddle points. We're done with this. Number 7. Do you remember with this question? Are we done with number 7? Can you reply in the chat box? Yeah, yes. Yeah, because it's here, review number 8, and then it's part 2. Oh, we still have lots of time. And then we only have This is 8, 9, 10, 11, 12, 13, 14, 15, 16. So you only have 9 questions to review? Oh, wait. Okay, that's 7. Okay, for number 8, we have this one. How many saddle points does the function have? I guess this is easy for you. Okay, so I will give you 8 minutes for this one. Is it okay? Your timer starts now. So for the saddle points, you need their fx and then fy. And then after that, um, you set that to 0. Fx is equal to 0. And then your fy is also equal to 0. And then you solve the values of x and y there. And then you have critical points. After the critical points, you do fxx and then fxy and fyy. So class also, the shortcut for this one is you solve the fx and the fy. After that, please solve the fxx, fyy, and then the fxy. You solve the d there. If your d is a number, it's just a number, so it's you can determine already if it's a saddle point or not. If it's negative, the d if the d is there is negative, the points that you will get are saddle points, right? Now if your d there is positive, so no need for you to get the critical points anymore. Because if that's positive, it means that it is a local point, it's a local maximum or a local minimum. So no need for you to do some efforts in getting the critical points. Okay. Again, the shortcut for this is solve the fx first and then fy. After that, the fxx, fxy, and then fyy. Solve your d there. Okay. That's it. So that you are not wasting your time finding the critical points. If your d, for example, is positive already, so no need for you to get the critical points anymore. Because for the saddle points, your D there is always negative. If you're done answering, you can write your letters there in the chat box, please. So we will finish like earlier. So what are we going to do is maybe we search for some questions for you to answer. Mhm. Maybe I can give you a short quiz after a surprise quiz. So please join the whole session because maybe we have a short quiz after. Maybe 8 minutes. It's too long. I guess you're done already. Okay, we can stop the timer now. And then I can see now your answers. Mm, see? Oh, someone answered already at 1:38. That's good. Hoi Li Pham Quam got the first answer. It's B. So let's see if it's letter B. Zero. Is it really zero? Okay. So we start with solving the fx. We have 4 times x minus 13 there. Okay. Because in here class, only the first term contains x. So the derivative of these two are 0 already. Now you apply chain rule. 2 times 2 here, it becomes 4. And then your 2 becomes 1. And then multiply the derivative of what's inside in your parentheses. The derivative here is only 1 because you have their x. Derivative of the x is only 1. So yeah, there 4 times x minus 13. 4 times x minus 13. And now for your y, this one becomes 0 and the 9 there becomes 0. So only this term will produce the derivative with respect to y. So 2 times here. So 2 times your y minus 8 and then your 2 becomes their 1. And then additionally you multiply the derivative of what's inside in the parentheses which is equal to 1 only because this is only 1. Yeah, that's it. Now equate them to 0. Again, as I told you, you did not get the critical points yet. Okay? But this is another way around. They get the critical points first. So here, divide 4 both sides. So x minus 13 is equal to 0. And then transfer the 13 to the other side. It becomes positive 13. Here, divide both sides by 2. So your y minus 8 is equal to 0 over 2. And 0 over 2 is still 0. So y minus 8, transfer that minus 8 to the other side, it becomes 8. So you have 13 and 8. Only 1 point. Now we solve our d there. And as I have told you, this is shortcut. Solve the d first. You have to solve the fxx first, the fyy, and then the fxy. Now they're all constant there because this is your fx. When you get the fxx, this one is 4x. So that's the only term with an x. The derivative of that with respect to x, it's 4. And your fyy, it's 2. Then your fxy here, fxy is you can get it here from your fx. And then there is no y there. So the derivative of this are all 0 in the fxy. That is why, as I told you, that is the shortcut. They're all constant. Substitute that in the equation. 2 minus 0 squared, it's still 0. The answer is 8. Now, as you can see, your d there is positive. And if you have there a positive value of d, And then also the fxx is also positive, which is 4. So both are positive. It's a local minimum. So there is no way of having a saddle point. So that is why I told you do not solve the critical points first. After the fx and fy, you do the fxx first, fyy and fxy, and then the d. Okay? Now, if you see the d is always positive, so that's it. Automatically, do not um you have to realize that if it's positive, it's either local minimum or local maximum. So it's impossible now to get a saddle point, and then you will say that the saddle points there, the number of saddle points is 0. So the answer is letter B, 0. Okay? And that's it. By the way, no need for you to determine the critical points there. And no need for you also to say something about the critical point. Is it a local maximum or local minimum? Because that is not our concern. The question there is asking for the number of saddle points. Okay? And that's it. You don't need to classify the critical points. Is it local minimum or local maximum? Okay? That's not the question. And that's it. Next we have number 9. Let P be the tangent plane to the paraboloid Z. We solved this kind of problem already. You can go back there in the part 1. Okay? You find it there. And then the technique there in solving is the same with the technique here. How to solve this. And that's it. And the formula is there also. Okay, your timer starts now. Maybe 8 minutes is for you to find it. Yeah, if you forgot how to do this. You need an fx and fy here, and that's it. By the way, the formula here I use is different from the formula there in the previous. So you will notice later the difference. And by the way, they are just almost the same. It's just that I replaced the variables there and it's okay. I guess the time it's too long. Maybe you're done already. Please send your answers now. Okay. Oh, mm. The first one who sent it, it's Kang Hong Fook. Letter D. Is it D? 5366. Okay. But before we answer that, I can now give you your 10-minute break first. Okay? And that's Hello, class. So after we're done with this, I prepared a quiz. Ready? I will give it after we discuss all the questions. Okay? So maybe after the break. Okay. So we have this one. First, you get the fx and then fy. No need for you to do the step one. So this is your fx and this is your fy. They label it like zx and zy. They're just the same. So if you see it here, um, yeah, because they didn't replace the z there. So you can replace that with f of xy there. And then fx now is 12x. And then your fy is 4y, correct? It's here 12x and then 4y. Now you substitute the points that you have there. It's point 1 to 10, right? This is your point M. So your x here is 1 and your y is 2. So we have to use that. Okay, so we substitute x here in the 12x. So that's your zx of 1, 2 is 12. And then your zy of 1, 2 is 8 because this is 4 times 2 here. Your value of y is 2. So that's 12 and 8. Now you substitute it here. Okay, so we use here x sub o, y sub o, z sub o. I guess this is not the variables that we used there previously, but they're just the same if you use it like this. So this is your x sub o, 1, your y sub o is 2, and your 10 is the z sub o there. That is why it's now z minus 10, okay? And then your zx of x sub o, y sub o, which is zx of 1, 2, it's equal to 12, so replace that with 12. Then x minus x sub o, your x sub o here is 1, so that becomes x minus 1. Your zy, it's 8 already, so replace that with 8. And then y minus y sub o. Again, this is your zy x o y sub o. This is actually equal to your zy of 1, 2 because your x sub o there is 1, 2. We have there 1. You have this here. Zy of 1, 2 is 8. That is why this becomes 8. And then y minus 2 there. Now you solve this. This becomes 12x minus 12. And then this one is 8y minus 16. Now transfer the 10 there to the other side. It becomes plus 10 there. This is 12x, copy 8y, and then minus 12 minus 16 is negative 28. Now when you do plus 10 there, then minus 28 becomes negative 18. And this is your equation of your tangent plane P. Now, to verify if these points are there, 1 to 15, 1 to 12. So you have to substitute there 1, 2, 1 in your x and 2 in your y. Is it 15 or 12? If you do that here, 1 and 2. So we have there 12. 12 times 1 plus you have there 8 times 2. It's 28 minus 18. The answer is 10. And you cannot see there the 1 to 10. It's not here. So we have to pick the next points. The next points that we have is 5, 3, 61 and 5, 3, 66. So you try there 5 and 3 in your x and y. So what z can you solve there? Is it 66 or that one with 61? 5, 3. So 12 times 5 plus 8 times 3. That's 84. Then minus 6, 18. We got 66. So it's here 5366 is the answer because when you substitute there 5 and 3 in your x and y, the answer is 66. So the answer is letter D. And all your answers there are correct. Now next we have question number 10. Hmm, this one, evaluate the double integral 10x squared dA. So your dA there, just replace that with dy dx. Why it's dy dx? Your y is bounded by functions, it's from 0 to 12 minus x squared. So 0 is here in the inner integral, going to 12 minus x squared. Now this is 12 minus x squared. They're all equal to y with here. Y is equal to 0. So your 12 minus x squared is equal to 0. Correct? Now you solve the two values of the x there, and you substitute it here in the outer integral. That's the boundary for your x there. And you will solve the integral directly. Okay, still I can give you here with 6 minutes for that. Your timer starts now for this number 10. Class, please use your pen and paper to answer the questions so that um, you know, or you can estimate the speed of your solving for this kind of problem. I guess some of you are not solving it and not writing their solutions there. Are you using an application to answer this question? Please do not do so. You have to write there. That is why I give you some time so that you can do some practice in solving these problems. Okay? class that you are you are writing the steps on how to solve it and then the shortcut that I mentioned so that you will not waste your time there in solving questions during the tests. Time is up. So what's your answers? Did you really answer it? So we have Fo Coin Tien. You get the first answer, C. Did you really solve this one? Can I ask for your solutions? Did you really write it? This is easy, right? Yeah. Just solve the inner integral class and that's fine. For the boundary, you have there, please equate this first. The 12 minus x squared is equal to 0. Then that would be x squared is equal to 12. Take the square root both sides. You can use positive and negative square root of 12. It's fine. Or you can use this one, positive and negative 2 square root of 3. And that's it. This is your boundary for your x. Now for your y, it's from 0 to 12 minus x squared. Okay? And you have this now. 10x squared, your dA becomes dy dx, and your y is bounded from 0 to 12 minus x squared. And your x is here, the last integral. You have there the outer integral from negative 2 square root of 3 to 2 square root of 3. Again, you can use square root of 12 here, negative square root of 12 to square root of 12. Okay, next, solving the inner integral, we have, okay, this is the equation here or the function here contains x and this is dy. So what to do, this one is considered constant, correct? The 10x squared is considered constant. So again, just multiply y there and then your y evaluate it from 0 to 12 minus x squared. Now you substitute y there, it becomes 10x squared times 12 minus x squared. Again, class, for this one, no need for you to multiply this or to simplify this. Just replace this in the inner integral and your calculator can do that for you. So it's like this. It's like this in your calculator. So again, no need for you to solve it like this here. For this one, your calculator can solve that. The answer is C there, 1330.215. So class, in our quiz today, so if your calculator can solve that directly, so no need for you to simplify it. Please do not simplify it anymore. Okay, so you had to write your solutions there the shortcut way. Okay, because it's like a practice if you take the test. Okay, so I need your solutions there, but the shortcut one. So imagine that you are taking the test later. Okay, next. So again, that's how to answer the quiz for today. You will not give the detailed solution for your solving there. If your calculator can do that directly, please do not solve that anymore, like manually. Okay, for this one, number 11. This is very easy. I can give you like 3 minutes for this. Your timer is now. If your f of xyz is equal to 0.7 x to the fifth yz minus sine of 0.1 times z there. So find or evaluate f of 1, negative 1, 0.6. Just substitute it there. Your x is 1, your y is negative 1, and then your z is 0.6. And you can solve that directly with your calculator after you substitute it there. So when you solve this kind of problem, class, you have to substitute there the values. Okay, you have to show that, and then after that, you can calculate it directly. So no need for you to uh, manually calculate the first term and then minus. You calculate this also, so no need. You can just calculate that um, in just one line, right? And then click equals, and then your calculator will give you the exact answer directly. And you do that way in when you answer the question later. The questions that I prepared for you. So I have a problem. How are you going to submit this? Hmm. Now, are you there in the classroom? If you are not there, how can you submit the quiz? So I'm hoping that you are there. Or, yeah, you can submit it online for today. All you have to do is to take photo of your paper and then send it to my email. Yeah, because I didn't announce this quiz. Okay, time is up. So what's your answer here? Type your answers now. B? So the first one who answered it, it's Bao Ling Cook. B. Yeah, it's B. Okay, so how to solve that one? Just substitute it there. 1 for your x, your y is -1, your z is 0.6, and then sine of it should be 0.1 times 0.6. 0.1 times 0.6 is 0.06. That is why it's here. Now you solve that in just one line. Your calculator and your calculator will give you -0.48 there. Next question, 12. 12, 13, 14, 15, 16. So we only have 5 questions left. Okay, so can I give you like 6 minutes for this one? Your timer starts now. By the way, I am preparing for a quiz for you. And it's here. I'll pick the difficult one. Where's the difficult one? Pick it. Where? Ah, it's here. Tick, tick. Thumbs up. What's your answer here? That's linear approximation. It's chapter 1, part 3 there. What's your answer? Why there's a V there? Oh, the first one who answer it, it's 18, 20. Oh, who's the first one here? It's a continuation. 26, 85, 24. The last one who sent it's here 12. B. Is it Bauli Nguyen Cook send the first answer B? You have their number 12, right? B 0.46. And you have this F, your Fx, and then your Fy. That's the value given. Then use linear approximation to approximate this. Your F is 7.01, 1.98. This is your X here, 7.01. And this is your Y. Okay, so we have this in the formula. Okay, for this one, it doesn't use the X sub O, Y sub O. So it uses the A, B there, and it's okay. They're just variables. So we have there fxy, we have 7.01 and then 1.98. It's approximately equal to f of AB, which is given already. We have zero point 0.5. Your fx, you substitute it here, negative zero point 0.6. Now, what is your x minus a? Your x is 7.01 minus 7. Your a is 7 because it's here, 7.2. So that's it. F of AB is f of 7, 2. So your A is 7 minus that one is 0.01. That is your x now minus A. And then your Fy of AB, it's there in the given 1.7. Then your Y minus B, your Y is here 1.98. So minus your B here is 2 because it's here f of 7, 2. Minus that one, it's negative 0.02. Again, you can calculate that with your calculator automatically. So your answer there is 0.46. Again, class, do not solve this individually. If you because you're using calculator, you have to give me the shortcut, and it's here 0.46. So you do that in answering the questions later. Next, you have this, in which equation from the above gives an equation of a cylinder. Number 13. Um, yeah, can give you like 4 minutes for this one. Your timer starts now. Where from that set of points? So we still have 20 minutes, so 13, 14, 15, 16, and 20 minutes. So we will have it until 2:50, and then you will have your break time, 10 minutes. Then after 10 minutes, we will start our quiz. Okay? By the way, the quiz is so easy class for you to do. It's only few questions. How many questions do you want? You want 10 questions? I have now 8. Time is up. So I'm done preparing class for your quiz already. Okay, there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it's 11. I will remove one question. Okay. So for this one class, we have a format for cylinder. It should be like this. X squared plus y squared is equal to r squared. This is a cylinder in R3. And then the key feature is no z in defining the equation. The shape is constant in z. So you have no z here in the formula. And where is it here that there is no z? So B, C, and E has Z there. So D is the only thing with no Z. So you can pick that directly because R squared there is equal to 2. So your R there is the square root of 2. And it has some explanation here. B there is a cone, this one. It's not a cylinder. And this one is an elliptic paraboloid. And then this one is no z at all, and then this one is a cylinder of radius is square root of 2 about the z-axis, and this is the answer. Now option E, this kind of function here is, this describes the upper hemisphere of a sphere of radius 1 there, not a cylinder. And then option A, none of the others, so incorrect because D is valid. So if your D is wrong, class, then you pick there none of the others. Now you have this one, and this is very easy for you to do. You can solve this like 4 minutes also, or three. Yeah, you can do that 3 minutes only. Just get the zx there, and then you substitute 0 for x, and y is 1. Time is up. So for this one, we solve the zx now. So we use this formula. Zx is equal to negative fx over fz. So first, what we did here is we transfer everything there to the other side, the equation. So you can use this one class. Okay. So partial of f over partial of x. So for this one, this is with respect to x, this is 0.3 z squared. And then this one with an x also. Here we have negative 1.1 z. And the derivative of this are zeros because there is no x there. Now partial of f over partial of z. Here, this is z squared here, so multiply 2 here. So 0.3 becomes 0.6, and then xz minus derivative with the z to the fifth, it's 5z to the fourth. And then this one 1.1 xz. So the x there is constant, so negative 1.1 x. Then there is now z here, so that's it. Now you have your zx is equal to negative your fx over fz. Now we substitute first the 0 and 1. You have here this point, right? 0, 1. We substitute it here first in the original equation because we don't have a value of the z yet. So that's 0 there at the other side, 0 also in this term, this one, because they have x and this one has x here and your x here is 0. So your y there is 1. So we are left with z to the fifth and 1 here plus 1. And that's it. You have there 0 and then z to the fifth plus 1. Transfer the plus 1 to the other side becomes -1. Then take the fifth root both sides. Your z is equal to -1. Now you substitute it there in the fx that we solve. For fx, it's only z there. So you substitute there -1. So we have that one, -1 squared minus 1.1 times -1. And then in your fz, your x there is 0 because that's 0, 1. So this one becomes 0 and this one becomes 0 because they have x. And -5z to the fourth. And your z to the fourth there, your z becomes -1. Right? So this one is +1 minus 5. So -5 in the denominator, we have negative. And then your fx, if you calculate that one, it's 1.4. So -1.4 divided by -5, it becomes now positive, which is equal to 0.28. Okay. Oh, who got the correct answer here first? The answer is letter B. And the one who got it, it's B. Chan, Kwan Chan Ngok Min. Okay, next. We only have two questions remaining. Yeah, we can finish this before the break, 2:50. So I will not give you your time anymore for this one. I'll just explain to you how to answer this. You have here finding the minimum value of this function. 1.9, 1.3, x minus 0.7 squared minus x squared plus y squared is less than or equal to 1.8. Okay, so if that is your disk there, so it should be the radius there is square root of 1.8, right? Because your 1.8 there is equal to r squared. So take the square root both sides. Your radius is square root of 1.8. So first we get the critical points first. We have an fx and we have a value, set that to 0. Your x is 0.7. Next, you get the fy, set that to 0. Your y is 0. So you have that partner, the 2 points there. You substitute it there in your disk and it's there inside. Now you substitute it in your f of xy and you have there 1.9. Okay, so we will find other points. If it's smaller than 1.9, then this is not the answer because it says there the minimum value. We are looking for a minimum value. Okay, next. If you have there 0.7, 7 as your x in the boundary constraint. So if you substitute it here, 0.7 plus y squared is equal to 1.8. Then when you solve that, your y squared there is equal to 1.31. So we use this information. Your x is 0.7, so you substitute it here in your f, and then your y squared, you substitute 1.31, and we have this. So 1.9, and then this one becomes 0 because you substitute there the x, which is 0.7. This one becomes 0, and your y squared there becomes 1.31, which is this. And if you solve that, it's negative 0.066. So you have this um, f, an f which is has this point there, negative 0.066. And this is the first negative answer that we had. The first that we had is positive, it's 1.9. So if we cannot find a negative value, then it's not a minimum. Okay, now we consider this point, the 0, and then the plus square, the positive square root of 1.8, because they are the points there inside your circles, and they are intersecting the xy plane. So you have there in your f, and the result is 0.17. Oh, it's positive, so it's larger than this. We're going to find the minimum. If you have the 0 and then partner with the negative square root of 1.8, the answer is 0.17. Now, if you have there square root of 1.8 and 0, the answer is 0. No, it's here, 2.435. So it's still positive, and then the square root of the negative square root of 1.7. So it's all positive. So only this one has a negative value, negative 0.66, and find it there in the answer key, and the answer key in the choices, and you cannot see it there. Therefore, your answer must be A, none of the others. For 15. Next, last question. Number 16. A point M has polar coordinates. Your R sub O is equal, your point is R sub O, and then pi over 6. Then your X is in standard polar coordinate system. X is equal to R cos phi, and then your Y is equal to R sine phi. So phi there is equivalent to pi over 6, and your R is equivalent to your R sub O. Now, given M lies in on the circle equation, x minus 21 squared plus y squared is equal to 441. Evaluate R sub O. So that is very easy to do. Just substitute it there in your x and y. So we have there cos of pi over 6, it's square root of 3 over 2. And then sine of your pi over 6, which is your y now, is R sub O 1 half times 1 half. Now you substitute it there in the equation. So your x now is equal to R sub O square root of 3 over 2 minus 21 squared. And your y now is R sub O 1 half squared is equal to 441. Now, your calculator can solve this directly. Since there is no R sub O there, you can use x there. Okay. And then it will give you two values. The x is 0, and this one, 21 square root of 3, or in decimal, this is 36.3731. And that's it. It's here, letter D. And okay, so I can now give you your 10-minute break. And it's here, the answer key. So I'll now give you a 10-minute break. So after this one class, please prepare your papers there and your pen because you're going to write. We will have a short quiz for 1 hour. I know, 50 minutes only. And you're given 10 questions and 50 minutes, so minimum like 5 minutes per question. But some questions there are so easy to do. It's only few are difficult. And that's it. You can finish like 30 minutes there. Okay, so we will now start the short quiz. By the way, you can open it in the part one. Additional information, part one. There at the last part, you will see there the short quiz. It's here, short quiz. So please do not change the numbering of the question. This is number one, followed by number three, number four. And next we have number five, number six. Next we have number 11, 13, 15, and 19 and 20. Okay? So please do not change the numbering. So it's there. You can open it. It's in the midterm one, a midterm review part one. You can open the questions in your LMS. Again, you have to show your solutions here, and then after that, you pick the letter of your choice. Okay?
Teacher, can I do on my iPad?
How to submit this quiz? Okay. Um, you have to take a photo of your answer. Again, you do you answer it with solutions, and your solutions are okay to be shortcut. Again, you try to answer it as short as possible. Um, yeah, because it is like a practice when you answer the questions on the test. Okay. So again, make your solutions shorter here. Wait, I will just send my email in the chat box. Maybe you know my email already. Um, by the way, who's there in the classroom? Hello. Can I request the paper to be collected? Hello. It's Dr. Tuk. Uh, Dr. Tuk, please collect the papers. Thank you so much. Again, you can access the questions in the midterm review part one at the last part there. We have a short quiz. And please do not change the numbering. It's 1, 3, 4, 5, 6, 11, 13, 15, 19, 20. No need for you to copy the questions. Just solve it right away. Again, uh, you do you do the solving as short as possible, and then when you can calculate it, so please Do not make your solutions here very detailed, okay? It's look like you are answering the test in the exam. So shorter solutions, right? Yeah, you do that as you practice for your quiz. We have here 10 questions, so that's 10 points in total. Then you should have solutions there. Okay, so to those who are in the classroom, please send it to your teacher there, Dr. Stokes. Okay, next, so to those who are online only, send your answers to my email. You have to take a photo of your answers and then send it to my email. Just photos, okay? Do not convert that into PDF because I can open it directly through photos. Just attach it there in the email and then subject. You have to write it like this, short quiz, short quiz. This is your subject, and then calculus 2, and then AP. AP means advanced program. Again, that is your subject, short quiz, calculus 2 dash AP, and send that to my email. Just send photos, okay? Take a clear photo. Okay, deadline. To those who are online, since you're going to take a photo of that, deadline is 4. I'll give you like 10-minute extension because it takes time to take a photo and send it through email. I guess 10 minutes is enough for that one. So deadline is 4 o'clock. And the deadline for those who are in the classroom is 3:50. Again, please tell me if you cannot access the questions. So I can show 1 to 4 questions, maybe like after 10 minutes, I will show the questions for number 5 to 6. Okay, so to those who cannot see it there, and to those who do not have laptops. So after 10 minutes, I will change this. Or wait, um, I will just combine some questions there. And I cannot make it small, so it's okay. So after 10 minutes, I will change this. Again, it's better if you can access the slides class in your LMS. It's there. Midterm midterm 1 review, part 1. Again, the questions for the quiz can be accessed in your midterm review part 1, the last part, last 4 pages. So to those who are just connected here online, na, 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 na. Take.
Teacher,
Okay. If if you do not have an access in the LMS, you can take a photo of this there on screen. Okay, I'll give you like 1 minute to take a photo of this. Maybe you cannot open question number 4 anymore or 3. You're not yet done. Okay, I'll give you 2 minutes there. Please take a photo of this so that you'll just have to, yeah, you can use your phone there. You can view the questions there and then you write it on the paper. Again, you
Hello, teacher.
short as possible. If you can calculate it with your calculator and so do not make it detailed. Okay, next this question 5 and 6. You can take a photo there. Again, this is for those who do not have laptops there. You can take a photo of that and then you can open your phone while answering. It's okay. Okay, can I just show you all questions like for 1 minute so that you can take a photo of this there? Then after that, I will show you again the questions, like 10 minutes each for the second slide to fourth slide. So next one, we have this 11, 13, 15. Again, please do not change the numbering. Where that's 11, you have right there number 11. So take a photo for this now. This is the third slide. Okay, I will now change for the last questions, 19 and 20. Then after that, you can go back now to your seats and then answer all of them. Or class, if you have a seatmate there that can access through his laptop the questions, you can take the question. You can take a photo of the questions there in his laptop, the questions only. Do not. And to those who, if your classmates will ask you the questions, please cover your papers also. Do not show it to them your answers. That's it. Okay. So we will now go back to number 5 and 6. So after 10 minutes, I will change this.